In this video, I'm going to walk you through getting started on writing a new web application in Go using Gin, a Go web framework, Heroku as your deployment platform, GopherJS so you can write Go instead of JavaScript for your client-side code, and PostgreSQL for your database. I'm going to assume you already have a basic understanding of Go, Git, HTTP, HTML, CSS, JavaScript, SQL, basic web development, and Go language stuff already. But if your knowledge of these topics is really rudimentary, you still can probably just follow the steps I give you by rote and still do okay. So in our stack, we're going to be using Go 1.11, and that's important to use the latest version because it has this new feature, Go modules, which is a new way of doing dependency management built into the Go tool itself. So we're not going to use Go vendor or Go deps or any of those alternative dependency management systems. We'll use Git, of course, for version control like most people do these days. Gin is a Golang web framework, in quotes here, because I don't think it really quite constitutes a full framework, which is, I think, good. It's more like a library that provides some conveniences for you. I find it pleasant enough to work with, and it's something that you can take piecemeal. It's not imposing a huge amount of structure on your code that's going to be difficult to extract later. We'll be using Heroku for the hosting platform because it's easy to get going and free for a simple starter project. Even if later on you want to move to some other hosting platform, that won't be a huge problem down the line. Heroku is just a good way to get started. We'll use GopherJS so that we can write Go code that compiles into JavaScript so that it can run within the browser, allowing us, if we choose, to bypass writing any JavaScript whatsoever, which I like because you can just stick in one language for both the server side and the client side. Although if your client code, if you think it's not going to get very elaborate, if it's going to stay very, very small, I don't think there are many advantages to Go at that scale. But the larger your client side code gets, the more you're going to want static typing and also just some other niceties that I appreciate about Go, certainly relative to JavaScript. And lastly, we're using Postgres for the database. That's generally the best option these days, and Heroku makes it quite easy to integrate Postgres into your project. So first things first, to get started, you're going to want to install Go, making sure you have version 1.11 or later. Install Git if you don't have it already. You can install the GopherJS compiler simply with this command, go get you, github.com, GopherJS. And if you don't already, make sure that your Go path bin directory is in your path so that you can just type GopherJS in any directory and it'll recognize the command. Lastly, you'll need to create a Heroku account if you don't have one already and install the Heroku command line interface. Once we have everything installed, we want to get a simple Go web app written with the Gin framework running on a local system. So if you haven't already for your new project, create the new repo on GitHub, make sure to check the box to knit the README, and then clone from GitHub to your directory of choice. And because we're using Go modules, you don't have to put the directory under the Go path. In fact, I would recommend you put it just elsewhere. So once you have a new project directory, inside that directory, create main.go and put the text you see here on the right in that file. Create a templates/home.temple file. And it doesn't really matter what's in there. Just put any HTML if you like. I'll show you some sample HTML on the next slide you might put in there. And next, because we need to tell the Go compiler that this project is going to be using Go modules, in the directory you run go mod init. That'll create a go.mod file in your directory, which contains a list of all the dependencies of your project, which for now is just going to be the Gin framework. So far, everything else we're using is in the standard library. And when now we run go build, the Go tool will recognize the Go mod file. And then as it compiles our code, it looks at the imports and adds any dependencies into the Go mod file as appropriate. Like it's going to add the Gin import into our Go mod file. And this just happens every time you run go build. It looks for any new imports that aren't yet in the Go mod file, and it just automatically adds them. And in the Go mod file, on each dependency, it'll put a version number. And automatically, it's just assuming right now that you want to use the latest version number. But it's important that it records the latest version now, because down the line, as we continue working on our project, if a new version of Gin comes out, what we don't want to have happen is for the Go tools to automatically fetch that latest version. We want to approve if we're going to use new versions of our dependencies. So the point of the Go module system is that it gives us control when our dependencies update. We have to actually positively affirm that we want to use the newest version rather than just stick with the version that's been working for us. So that's the primary thing Go modules are about, which might sound like a bit of extra work, but it's generally the saner policy. Next, because we're deploying to Heroku, the way Heroku works is that your whole repository gets pushed up to the Heroku server, and it's run in a Docker container. and it expects to find everything it needs to build your program in that repository. And so we're going to need to actually bring the source of our dependencies into our project directory. And we can do that with go mod vendor. It automatically will create a subdirectory called vendor, and in there it'll store all the source of our dependencies. At this point, Gin and all of its dependencies. So be clear that when we bring in new dependencies, we're going to first need to rebuild our project to update the go mod file, and then run go mod vendor again, so it can copy anything that's not already in vendor into the vendor directory. Because otherwise, we're going to push up to Heroku, and it's going to be missing dependencies that it needs to build. Okay, so now everything's in place, and we can actually run this program. And if you look over at the code, you'll see that the port our server is going to run on is specified through an environment variable, port. When deployed to Heroku, port will automatically be set to 80, as you expect for a web server, but here on a local system, we'll want to use some other port number. And in the Unix shell and bash, when you run a command, when you run a program, you can set environment variables just for that execution. And so we do that here. Whatever your executable is called, you put that after // but before that you specify, let's say 5000 for the port. Run that command, our server will launch, and you can go into your browser at localhost:5000, and you should see your web page. I'm not going to go into any details about the Gem framework here. It's a quite straightforward framework, and if you've done any web server programming before, it's easy to pick up. The documentation is quite clear. But just really briefly, what's going on here on the right is gin.new, that creates a new router. We set up serving template files from our templates directory. Later on, we're going to need a static directory for serving so-called static resources like your CSS, your JavaScript files, etc. And other than that, we define simply one route, the root for /, which is just going to simply render the home.template file, which is just going to have whatever HTML you put in it. After all of our routes are registered, in this case just the one, last thing we do in main is we call run on the router, specifying what the port number is. And that's what actually kicks off the web server. That's when it begins serving. So what about that HTML? Well, again, it doesn't really matter what it looks like at this point. You just want to see something on the screen. But I would recommend, firstly, making sure your HTML has a title so that you can recognize it in the tabs of your browser. If you're like me, you tend to have a million tabs open, so it's nice to be able to quickly identify your tab. Also, for that reason, it's a good idea to, very early on in your project, make sure you have a fav icon set up. You don't have to pick the ideal fav icon, just something that's recognizable. There are a lot of sites online you can go to find icons, and there are sites you can use that'll convert like pings and GIFs and whatever into the eco format. So just make sure you have a fav icon file in your static directory, and then this link tag will tell the browser where to find your fav icon. And also be sure to early on set up a CSS file. Otherwise, you'll be tempted to put all your styles directly on tags, which is a very sloppy style as much as possible. You want to punt your style stuff into a CSS file. So that's a good start on your HTML. Now, how do we actually deploy to Heroku? Well, from the command line, once you have the Heroku command line interface installed, first do the Heroku login command, which will prompt you for your Heroku password. And then using Heroku create, you pick a new Heroku app name, which has to be unique among all existing Heroku apps. So if you pick a name that's already in use, you're going to get an error. You might at this point just omit the name and Heroku will pick one for you. It'll just generate some nonsense name for you. Anyway, do make sure to execute the create command in the directory of your project, because it'll recognize there's a Git repo there, and it'll set up a new Git remote for you called Heroku. And so if you then git push Heroku master, that'll push the master branch of your local repo up to Heroku, and it'll automatically then try to build your project. And if it's successful, then your application will be deployed at the URL of whatever your project name is, .herokuapp.com. As a convenience, from the directory of your project, you can type Heroku open, and it'll open that URL in your browser. Be clear that although we deploy by git pushing to Heroku, you really should not be using Heroku for version control. In fact, I don't think they make any guarantee of preserving the remote repo on their end. If you shut down the application, it may actually lose your code, I believe. So you're going to be using your GitHub account or whatever Git service you use as the real remote repository for your project. So say you're working on your project, you make some commits, and then you push them up to GitHub, and then only when you're ready to deploy do you also push to Heroku. And when you coordinate with other people on the project, when you pull, you're always pulling from GitHub. I'm not even sure what happens if you try and pull from Heroku. I think it might actually give you an error. So in general, you're just pushing to Heroku simply when you want to deploy, and that's it. Okay, now let's bring GopherJS into the picture. We're going to create a subdirectory Go.js for all of our client-side Go code. and in there we'll create a main.go. It doesn't have to be called main.go. You can call it whatever you want, but it has to be a package main file. And in this package, we're importing the GopherJS JS package, which is a package that lets us, from our GopherJS code, access the JavaScript environment to get and set global variables, and through it effectively access the browser APIs. So here in the main function, js.global is the global namespace object, and from that we're getting the document variable in the global namespace and assigning it here to doc. And then in the next line we use printline to print out to console. What you don't want to do is use fumpt. If you use fumpt.print or printline, it doesn't actually print out to console. And also the problem is the fumpt package, because it uses reflection, anytime you bring in the fumpt package in your GopherJS code, it inflates the size of the compiled code by like a megabyte. It's huge. So the general rule in GopherJS is we avoid fumpt and any package which relies upon reflection, because the reflection code, for a variety of reasons, requires bringing in all this stuff, which is huge in the compiled output. So be careful about that. So having created the subdirectory GoJS and main.go inside it, we then want to build it. So we cd into the directory and use GopherJS build, which is just like go build, except instead of an executable, it'll spit out a JS file in that same directory. And we want our web server to be able to serve this JS file. So we're going to add a static route that exposes the entirety of the GoJS directory as GoJS. And so in our HTML, we can add the script tag referencing the GoJS file generated by GopherJS build. And it's important actually that we expose the whole GoJS directory rather than just a single GoJS file, because GopherJS build also spits out a .map file, which is used by the browser when we try and debug our code, instead of having to debug the compiled JavaScript code, which is going to be difficult to read, and it's simply just not the code we originally wrote in Go. We want to see the Go code when we debug. Well, the map file allows us to do that. In the browser debugger, we can open up the actual Go files and set breakpoints on them and step through it like we're stepping through Go code, not through the underlying compiled JavaScript. But this only works if the browser can see our .map file and all the Go files. It needs to actually be able to access them like it accesses any other resource through the server. So that's why we're statically serving everything under the whole GoJS directory. Normally you would say it's a very bad idea to serve your actual code to your users, but of course, this is Go code that's compiled into JavaScript anyway, and so, even through minification, they still get your code in one form or another. So it's not like we're really hiding anything, and you shouldn't put sensitive things in your client-side code anyway. So maybe in production, you make sure that you're serving just the single compiled JavaScript file instead of the map file and all the Go files. But I'd say it's hardly a real security concern. Your security probably shouldn't hinge upon the obfuscation and minification of your JavaScript code. Now, I'll talk more about GopherJS in a later video, but an important thing to note here is we're not using Go modules, which I think is now supported in GopherJS. I could be wrong about that. I'm sure it will be at some point in the future. But we don't really need to use modules here because we don't need to put things in a vendor directory. We're going to make sure that before we push up to Heroku that we first use GopherJS build to build the latest version of our JavaScript code, and then make sure that's committed into our local repo, and then push up to Heroku. Heroku is not going to be building our client-side Go code. We're just going to be doing that locally on our machine. It, of course, could be done to set up the build process on the Heroku side so that it actually does run the GopherJS tool and actually compile your code on the client side. Arguably, that would be more convenient and less error-prone, rather than us having to remember to make sure to compile the JavaScript code before committing and pushing to Heroku. But here, we're just going to keep things simple. We're just going to do it manually. So now, if you compile your client-side code and then recompile the server because we added that new route to the server, we can run the server locally and navigate to localhost 5000, and you should see the content of your web page. Plus, also in the console, it'll have that print line message from our Go code. Our client-side main function is executed when the page loads. If you go into the Sources tab, you can navigate to your client-side Go files, and then you can actually set a breakpoint. We can set this breakpoint, and if I were to reload the page, then it would break on that first line of main. The last step here is we're going to want to set up a database. Do be clear about Heroku, the nature of the containers that it runs, what they call dynos in their terminology. These dynos, they don't have any persistent storage. For one thing, every time we push up to Heroku, when we push the latest version of Heroku, it just flushes everything and starts again with a new container. So anything we store in the file system in our container is not going to persist between new versions of our code. That's a problem. And then on top of that, your dyno containers automatically are put to sleep after periods of inactivity. And when they're inactive, Heroku makes no guarantees about restoring the full state when it wakes up again. So after your initial successful build, it'll save that state. But then anything that happens from there, when your dyno falls asleep and then wakes up again, it'll often roll back to that state. So you can't really preserve anything. You can't store anything permanent directly in the dyno container itself. You need some kind of Heroku storage add-on, and there are many different add-ons. The one we'll be using here, which is a Postgres add-on. And so the first thing we do within our project directory is we use the Heroku add-ons command with :create and specifying the name of the add-on we want, which is Heroku-PostgresQL :hobbydev. Hobbydev is the lowest tier plan, the one that's free, which is limited to, I think, like 10,000 rows in your database. So it's good for just like starting up a web project, but as soon as you have actual real users and actual data storage needs, you're going to want to upgrade to an actual paid plan. But for our free project, just getting started, it should be fine. Having created the add-on for our project, in our server-side code, we add imports for database/SQL. That's the standard SQL package, but that's just the interface. We need a so-called database driver behind that, and that's why we also import libpq. PQ as in Postgres. I don't know why they abbreviate as PQ. And the reason you put underscore in front of the import is because we're not actually going to be referencing anything from the PQ namespace. In the PQ package, there's an init function which is run at the start of our program, and that registers the Postgres database driver with the SQL package, such that when we use the open function from the SQL package, we can specify that we're using a Postgres database and it knows what we're talking about. You see that down at the bottom on the left, where SQL.open Postgres. Without importing the PQ driver, it would have no idea what kind of database we're talking about, and that call to open would return an error. So you see there at the bottom, that's how we open the database. Put that somewhere in your main towards the top. The second argument to open is the connection string, which when running on Heroku is going to be provided through the database URL environment variable. And we have to get the connection string this way from the environment variable because Heroku makes no guarantees about that connection string being stable. What the connection string is supposed to be changes dynamically. So we need to make sure that Heroku, when it starts up our server, it is programmatically getting the latest version of what the proper URL is. So assuming this succeeds, error will be nil, and DB will be assigned. It's not a connection, it's this thing that represents the SQL package connection pool, but it's the thing we use to invoke SQL commands when we use this package. As a demonstration of using this thing, on the right you see another route we might add to our code for /tick. So when we navigate to /tick, it'll run the code you see here, which will create a ticks table if it doesn't already exist. It'll insert a new row into the ticks table, which is just the current time. And then the third query there will get all the rows from the ticks table. And that query returns a rows object, which is a kind of iterator object. And down at the bottom, you see a loop where we're calling rows.next to go through all the elements of the rows. The scan method there is used to actually extract the value from the row into a Go variable, the variable tick of type time. And at the bottom, c.string, that is tacking on the tick to a string, which is the response body for this HTTP request. So in this route now, once our server is running, when we navigate to /tick, we'll see a list of timestamps, and every time we refresh, that list will have one more entry. Because every time we visit this route, we're adding another timestamp to the ticks table. That's a very brief introduction into the SQL interface, which is quite complicated and a whole topic unto itself. Probably something I'll tackle in another later video. But anyway, now with all this code in place, let's run go build again. And because we've added a new non-standard dependency, in this case the PQ library, we're going to want to make sure that's in our vendor directory, so we run go mod vendor. And now we could deploy to Heroku and then run the application remotely. But if you want to run the application locally, we need to specify the values for the environment variables, port 5000 like we saw before, but also we need to specify a value for the database URL, which, as I mentioned, is dynamic. It's not fixed. And so what this bash syntax does, the $ with parentheses, is in those parentheses are another command, in this case calling Heroku config, which will echo out the config value for our database URL. And we specify after the hyphen, you specify the Heroku name of your application. So that Heroku config subcommand, it's going to spit out the URL, and that's going to be inserted in place of the $ parens. And so that's going to be the value set to database URL when we run our server. Now be clear that in this setup, the server running locally and the server running on Heroku both are using the same database. And this might be a problem for your development. You may prefer to have a development database, a database that's just used for Scratch for development purposes, where you don't really care about losing the data. That's generally a good idea. So what you might want to do is set up Postgres on your local system and then use that database when running your server locally. That is one solution to this problem. That's probably the simplest thing to do. Regardless, now that we have our server running, we can open up localhost 5000 in our browser and navigate to /tick. And every time we reload, the list of timestamps we see will grow by 1 each time. So that's how to set up a Go web app using Heroku with Gin and GopherJS and Postgres. If you want to learn more about Heroku, I suggest you look at these links. There's some basic concepts that are important to understand. You should also learn more about Gin if you're going to use it. Pretty much everything you need to know is right there on the README of the GitHub repo. And next video, I'm going to go into more detail about using GopherJS.